The military world never sleeps. The modern battlefield is like a living organism that constantly changes, demanding relentless innovation, especially in defense technology. Amidst these dynamics, the United States Army consistently shows its ambition to stay at the forefront. They never stop looking for ways to enhance the three main pillars of land power, firepower, mobility, and protection for their soldiers. This hard work isn't just talk. We can see the proof in a series of ambitious development programs and the super advanced combat vehicles that continue to emerge. Each is designed with a specific purpose, addressing unique operational challenges, and most importantly, ensuring the US Army's dominance on land remains unshaken. Let's dive deeper into some key programs and platforms shaping the future of American armored power. The birth of the M10 Booker. One of the most crucial needs for modern infantry forces is responsive and lethal direct fire support. Imagine infantry troops advancing, suddenly blocked by an enemy bunker or light armored vehicle. They need something that can arrive quickly, has adequate protection, and possesses a powerful weapon to destroy the threat instantly. This need is the background for the birth of the Mobile Protected Firepower MPF program. The goal of the MPF program is clear: to procure a new combat vehicle that is agile, protected, but has a large caliber cannon to deliver a hard punch directly. This concept isn't actually new. The US Army has had similar vehicles before, like the M1128 Mobile Gun System, MGS. The M1128 was essentially a Stryker personnel carrier chassis fitted with a 105mm tank gun turret. The M1128 MGS proved the value of this concept. It could keep up with the rapid movement of other Stryker units thanks to its Caterpillar C7 turbo diesel engine, provide precision fire support for dismounted infantry, and was very effective at destroying enemy defensive positions or light vehicles in close combat. However, the M1128 also had limitations, especially regarding survivability and the logistics of its cannon's spare parts. Learning from the M1128 experience and the needs of the modern battlefield, the MPF program finally chose a winner. The M10 Booker, designed by defense industry giant General Dynamics Land Systems, GDLS. The M10 Booker was developed from the GDLS Griffin II prototype platform. Technically, the M10 Booker is often debated. Does it fall into the light tank category or not? The US Army itself prefers to call it an MPF vehicle, emphasizing its role as infantry support, not a main battle tank, MBT for tank-on-tank duels. What makes the M10 Booker special? Main gun. It's armed with the M35 105mm cannon. This caliber has proven effective against various targets, from buildings and bunkers to medium-class armored vehicles. Fire Control System, FCS. Now, this is one of its main advantages. The M10 Booker uses an advanced fire control system adopted directly from the M1A2 Abrams SEP V3 tank, one of the most advanced MBTs in the world. What does this mean? Its firing accuracy is exceptional, even while moving day or night in bad weather. This provides a significant advantage. Secondary armament. Besides the main gun, it's also equipped with an M240C 7.62mm coaxial machine gun mounted parallel to the cannon to engage enemy infantry, and an M2.50 caliber heavy machine gun on the turret roof for light air targets or unarmored vehicles. Protection. Although not as heavily armored as the M1 Abrams, its armor is designed to be modular, meaning it can be augmented according to mission needs, and provides much better protection than the M112 8MGS, especially against explosive threats and light anti-tank weapons. The importance of the M10 Booker is serious, so much so that its unveiling on April 8, 2024 at Aberdeen Proving Ground, Maryland was a major event attended by Army top brass. What's more touching, the name Booker was chosen to honor two heroic soldiers, Private Robert D. Booker, killed in World War II and recipient of the Medal of Honor, and Staff Sergeant Stephen A. Booker, killed in the 2003 Iraq War and recipient of the Distinguished Service Cross. This naming serves as a profound symbol of respect for their bravery and sacrifice, as well as a reminder for the soldiers who will be supported by the M10 Booker in the future. The symbolic moment when the Booker family broke a champagne bottle on the first M10 and the subsequent live fire demonstration truly marked the beginning of a new era for U.S. Army infantry fire support. Stryker X and Abrams X. General Dynamics isn't just focused on the M10 Booker. They continue to innovate with existing platforms, adding a touch of future technology. Two of the most interesting examples are the Stryker X and Abrams X. Both are technology demonstrators showing the potential of using hybrid, combined diesel-electric powertrains in combat vehicles. Why hybrid? Doesn't it just add complexity? It turns out there are many advantages: fuel efficiency and range. Electric motors can assist the diesel engine, especially during acceleration or at low speeds, making it more fuel efficient. This means the vehicle's operational range can be extended, which is crucial for long-distance maneuvers. Silent watch and silent movement. This might be the most tactical advantage. In pure electric mode, the vehicle can move or conduct surveillance almost silently and with a much lower thermal signature. Imagine how useful this is for reconnaissance or secret ambush operations. Enemies would have a very hard time detecting their presence. The next-gen Stryker X, based on the Stryker, demonstrates how an integrated series hybrid system can be installed in an 8x8 wheeled vehicle. Meanwhile, the Abrams X, although still a demonstrator concept, provides a glimpse of how future main battle tanks could become lighter thanks to an unmanned turret and potential crew reduction. More agile, more efficient, and more lethal with integrated hybrid technology and artificial intelligence. This isn't just about changing the engine, it's about changing the design and operational philosophy of the tank. Of course, challenges exist. Integrating high-capacity batteries, powerful electric motors, and complex power management systems into the limited space of an armored vehicle isn't easy. Not to mention the durability of these systems on the harsh battlefield, but the potential benefits keep the US Army and the defense industry pursuing this technology. NGCV, Next Generation Combat Vehicle. The US Army's modernization efforts aren't just sporadic on one or two vehicles. There's a giant umbrella program managing all this, called the Next Generation Combat Vehicle, NGCV. This program has now evolved and become part of broader modernization efforts, but its essence remains the same: drastically improving the capabilities of the entire combat vehicle fleet and developing revolutionary new technologies. This isn't just about making new tanks or IFVs, infantry fighting vehicles. NGCV includes the development of new generation manned combat vehicles, e.g. the replacement for the M2 Bradley. Robotic combat vehicles, RCVs. More advanced command and control networks, integration of AI and autonomous systems, more effective active protection systems, APS, directed energy weapons. The center of all this advanced technology research and development is the U.S. Army Ground Vehicle System Center GVSC at Detroit Arsenal, Michigan. This place is like the heart of U.S. Army ground vehicle innovation. It's where wild ideas are born, tested in computer simulations, realized as physical prototypes, tortured in extreme testing, until finally ready for integration into the force. GVSC works very closely with the defense industry and academia to ensure the U.S. Army always gets the best technology. The era of robotic combat vehicles, RCVG. One of the most futuristic outcomes of the NGCV program and its successors is the development of robotic combat vehicles, RCVs. This is no longer science fiction. The US Army is very serious about developing unmanned combat vehicles that can be remotely controlled or even operate semi-autonomously. The goal is clear: reduce the risk to human soldiers' lives. These RCVs are designed to perform the 3D tasks: dull, dirty, and dangerous. They can be the spearhead for reconnaissance, enter areas contaminated with chemical agents or radiation, or even engage directly in combat on the front lines while their operators remain safe behind. Currently, the US Army is testing 3 classes of RCVs RCV Light, RCV-L, small, agile, primarily focused on reconnaissance, enemy detection, and possibly carrying light weapons or electronic warfare systems. RCV Medium, RCV-M, larger, with more significant firepower, can be fitted with medium caliber cannons, like 30mm or 50mm, or anti-tank missiles, suitable for providing fire support or destroying enemy armored vehicles. RCV Heavy, RCVH, the largest and most powerful, possibly the size of a light tank, can carry large caliber cannons and has better protection. Its role could be breaching enemy defenses or escorting convoys. These RCVs aren't just about remote control, they are designed to be part of the manned-unmanned teaming MUMT concept. This means manned vehicles, like the M1 Abrams or the future Bradley replacement, will work together with RCV. Operators in manned vehicles can control multiple RCVs simultaneously, use RCV sensors to see further, or order RCVs to attack dangerous targets first. M2 Bradley. Speaking of US Army infantry fighting vehicles, it's impossible not to mention the legend, the M2 Bradley. Since entering service in 1983, the Bradley has been the backbone of transport and fire support for American mechanized infantry. It was designed during the Cold War era to counter the Soviet Union's BMP. The Bradley is more than just a battle taxi. Oh, it has a potent combination of weapons. M242 Bushmaster 25mm automatic cannon, effective against infantry, light armored vehicles, and even low-flying helicopters. Tau anti-tank missiles provides the capability to destroy enemy tanks from long range. M240C 7.62mm coaxial machine gun. Additionally, it can carry an infantry squad, initially 6, now up to 7 in the latest variants, with their full gear, deploying them via a rear ramp while providing suppressive fire. Its optics and sensors have also been continuously upgraded, providing good situational awareness for the commander and gunner. The Bradley has extensive combat experience from the First Gulf War, Operation Desert Storm, the Balkans, to Iraq and Afghanistan. It has proven tough and effective, although it has also faced criticism regarding its vulnerability to IEDs and RPGs in asymmetric warfare. Over decades, the Bradley has been continuously upgraded. There's the M3 cavalry fighting vehicle variant for reconnaissance, command variants, repair variants, and various armor and electronic system enhancements. Although the US Army is looking for its replacement through the optionally manned fighting vehicle OMFV program, the Bradley will likely continue to operate in large numbers for years to come, possibly operating alongside its successor. Armored Multi-Purpose Vehicle, AMPV. If the Bradley is the frontline fighter, there's another vehicle whose role behind the scenes is no less important, the support vehicle. For decades, this role was held by the M113 Armored Personnel Carrier APC. The M113 is iconic, used since the Vietnam War. It's boxy, simple, relatively cheap, and versatile. But on the modern battlefield, its protection is no longer adequate, especially against mines and IEDs. That's why the US Army developed the Armored Multi-Purpose Vehicle, AMPV. This program has one goal: replace the entire M113 fleet within the Armored Brigade Combat Teams, ABCTS, with a much safer and more modern platform. The smart decision was to base the AMPV on the M2 Bradley chassis, which is proven tough and has established spare parts logistics. However, the AMPV doesn't use the Bradley's turret. Its design focuses more on maximizing internal space and crew protection. Why? Because the AMPV has many variants with specific tasks. General purpose, for transporting personnel, cargo, or emergency casualty evacuation. Mortar carrier, carries a 120mm mortar for indirect fire support. Medical evacuation, an armored ambulance to transport wounded from the front line to medical stations. Medical treatment, a sort of mobile mini hospital to provide emergency medical care. Mission command, a mobile command and control center for commanders in the field. With the AMPV, these support units, medical, logistics, mortar, command, can keep pace with the fast-moving M1 Abrams tanks and M2 Bradleys on the front line without worrying about protection. They have equivalent mobility and survivability, so the entire ABCT can move as a cohesive and protected unit. This is crucial for maintaining operational tempo. The AMPV is also designed for future upgrades, just like the Bradley and Abrams. Rigorous testing continues, such as in the 𝗤𝗂𝗃𝗃 live fire demonstration at the 2024 Maneuver Warfighter Conference, to ensure the AMPV is truly reliable in various terrain conditions and against various threats. Breaching technology. The modern battlefield is full of obstacles, not just enemy fire but also minefields, roadside bombs, IEDs, barbed wire, anti-tank ditches, and other barricades. For armored forces wanting to move quickly, these obstacles can be a nightmare. That's why breaching technology is so vital. The U.S. Army relies on the M1-150 Assault Breacher Vehicle, ABV, for this tough job. This is a true monster built on the super tough M1 Abrams tank chassis. Its sole purpose: destroy any obstacle blocking the path of friendly forces. How does it do it? The ABV is equipped with two main tools: mine plow or mine roller, mounted on the front to dig up or detonate shallowly buried mines. Mine clearing line charge, 𝗤𝗃𝗃𝗀𝗃𝗃. This is the most spectacular. The ABV can fire a rocket that pulls a line charge containing C4 explosive over 100 meters long. This line falls across the minefield and is then detonated remotely. The explosion detonates or neutralizes all mines along that path, clearing a safe lane several meters wide for other vehicles to pass through. The ABV has proven its effectiveness in Afghanistan and Iraq, clearing paths through IED-laden terrain. Other countries also have similar solutions. Germany, for example, has the 𝗖𝗄𝗃 mine flail. Initially developed on the chassis of old M48 Patton tanks, there's now a new generation, the 𝗖𝗄𝗃-NG, using the Leopard 2 tank chassis. The 𝗖𝗄𝗃 doesn't use a plow or line charge, but a flail system. Imagine a large rotating cylinder at the front of the vehicle, with dozens of chains with heavy metal weights at the ends. As these chains strike the ground, they detonate any mines beneath them. Its accuracy is claimed to be very high, up to 98 to 100%. The 𝗖𝗄𝗃-NG can also be equipped with a Pearson mine plow, capable of clearing up to 250 meters per minute, and a rocket-assisted line charge system called 𝗤𝗄𝗃. Germany also has another unique technology, the mine clearing ladder. It's like a giant rope ladder whose rungs are filled with tens of kilograms of explosives. This system is launched into the minefield and then detonated remotely. In 30 seconds, the explosion can clear a safe path. Simple but effective for certain situations. Breaching technology might not be as glamorous as tanks or fighter jets, but without it, the movement of modern armored forces could be completely paralyzed.